find an angle using the calculator. So make sure you have your graphing calculator close by. As a 20-foot ramp 20 feet in length rises to a loading platform that's 3.75 feet off the ground. Angle of elevation of the ramp. As always, anytime we have a scenario like this, it's always best to draw a picture. So here's my ramp. I know that there's going to be a 90-degree angle in there somewhere. This would represent my angle of elevation. This would be, a person up here. Some kind of loading platform, whatever they're loading. Okay, and it said that it's 3.75 feet off the ground, and it's a 20-foot ramp. Okay, so just one thing I want us to keep in mind here, because maybe you'll have other scenarios. This says angle of elevation. So just keep in mind, when we're talking about angle of elevation, you want to make sure that we have a horizontal, and then we're looking upward. If you ever see a problem where it's talking about an angle of depression, you're going to have a horizontal looking downward, okay? So just if you ever have that kind of scenario in a problem set. Okay, so let's start by coming up with a trig equation here. Since we have theta and we have a value for opposite side in our hypotenuse, we're going to have sine of theta equals 3.75 over 20. But we're solving for theta. We want the measure. Now here it doesn't really specify if we want that theta measure in degrees or radians. When you have context like this, just think about what makes sense in this problem. Like it makes sense that we're talking about this in terms of degrees. So to find theta, here we have to use our inverse. Sine inverse of 3.75 over 20 would give us theta. So here's where I need my calculator. I'm going to type in, let's also make sure that our calculator is in degree mode. I notice that mine is, so I'm good to go. So I'm going to do inverse sine of 3.75 by 20. So we get that angle measure, that angle of elevation is about 10.807 degrees. Not too bad. Okay, so, we have other scenarios too where maybe it's not like a word problem where you have to draw a picture, but here, like if cosine of theta equals 0.4512, I want to know how many degrees, and also in radians, it says in the directions, would theta be for that. If I had a different problem, which you don't need to write this down, let's say I had cosine of theta is root 2 over 2. Like, this is pretty simple. I can just go to my unit circle and kind of figure it out that way. But, the difference with these guys is, we don't know on the unit circle where 0.4512 is exactly, right? It's not part of that. So, kind of similar to what we did in that previous example, find theta, we would do the inverse cosine of 0.4512. If I go to my calculator, we're going to have to find this in both degrees and radians. Currently, my calculator is in degrees, so I'll just get that one done and over with first. 0.4512. About 63.179 degrees. And to find it in radians, I gotta just quickly here change my mode. Radian. And I get that it's 1.103 radians. But if we think about this, that is part of my answer, but there's more to it. If I think about what this looks like graphically, cosine of theta has to be in either quadrant 1 or quadrant 4, right? So, let's say that this is theta. since theta is an even function, we know that cosine of theta is going to be equal to the cosine of negative theta. So what we're going to want to figure out here is like, okay, well, what about this? What if I'm looking for, here, let me draw these arrows here. For these values, what would this be in degrees and radians? Which we know, like, well, this could be negative 63.179 degrees. Perhaps I should write this down. I'm going to do it in gray just so we know that it's not our final answer. Like, I could say that this is negative 63 degrees or negative 1.03 radians. But check out our domain here. Okay, that's not going to work out. So how am I going to figure out what this is, what angle this is that's within our degree? Well, we just talked about coterminal angles. I could figure out its coterminal angle, right, by adding 360 and by adding 2 pi. So for my other answer for this, if I do that, I should get 296.821 degrees, and then 5.180 radians, which now both of those answers are within my domain. Okay. So you're going to try tangent of theta. All right. At minimum, you can at least go through your calculator and find, your answers. Go ahead and do that. All right, this one definitely required some more thought. So let's think about this one here. So when you first put this into your calculator, you notice that you get 2 negative answers. I mean, that's what I got. If you want to take a look at how I typed this in. I got a negative answer for my degrees and for my radians, which right away you're like, shoot, that's not part of my domain. So to get its coterminal angle, of course, we add 360 and add 2 pi, which is where I got this answer. So think about now tangent. I've got tangent of theta equals a negative number, which means, I could either be in quadrant 4 or I could be in quadrant 2. So the first one that I got was in quadrant 4. And I do want to figure out, okay, well, what would my solution be in quadrant 2? Just think about the positive and value signs of your x and y coordinate. Either one of them could be positive or negative, as long as, I am dividing those same two numbers. So this was negative 56.310 degrees. I know, going across here, that this would be, 56.310 degrees away from 180. So if I do 180 minus that value here, I get my my other answer at 123.69 degrees. And I could do the same thing in radians. So to conclude, we know how to use the inverse function on the calculator to find an angle. Be aware of what the angle should be that you are looking for, because the calculator might not give you the correct angle initially. So maybe you have to restrict or understand, like, what's our domain. Also, is it possible to have more than one solution?